Okay, madam, my name is Divesh Ravindran from class DEP2A and my matrix number is 10DEP20F2030. Today, our topic is explain the characteristics and the electrical properties of semiconductor.
My name is Satya Loganathan. My matrix card number is 10DEP20F2034.
Hi madam, my name is Sugan Roshan, son of Tanabalan. My matrix card number is 10DEP20F2033.
Hi madam, my name is Suventiran, son of Krishnan. My matrix number is 10DEP20F2032.
Hi, madam. My name is Avinay Subramani, and my matrix card number is 10DEP20F2020.
Okay, first introduction. Electronic materials have three types. First, conductors, materials that easily conduct electrical current. Second, insulators, material that does not conduct electrical current under normal conditions. Third, semiconductors, materials that is between conductors and insulators in its ability to conduct electrical current. Okay, now the characteristics of semiconductor. Semiconductors are substances that have special electrical properties. The substance that allows current to flow through is called an electrical conductor. Besides, a substance that does not allow electricity to flow through is called an insulator. Semiconductors are substances that have an intermediate electrical conductivity. It is between the conductor and the insulator. The electrical conductivity of a substance is characterized by its resistivity. Conductors such as gold, silver, and copper have small resistivity. That makes it easy for them to flow. Insulators such as rubber, glass, ceramics have high resistivity. That makes it difficult for them to pass through. Semiconductors are electrically conductive and in the middle of the two types. The value of the resistivity may vary with temperature. For example, with semiconductors at low temperatures, they almost do not allow electric current pass through. But when the temperature rises, they allow the electric current to pass easily. Used semiconductors do not contain impurities that are almost non-conductive. But when doped with some impurities, they become more conductive and let the electricity flow through them easily. Semiconductors consist of a single element called elemental semiconductors. For example, the most common semiconductor is silicon. Semiconductors, on the other hand, are made up of two or more components called semiconductor compounds and are used in semiconductor lasers, light emitting diodes, and etc. That's it. Now Satya will be continued.
Properties of semiconductors. Semiconductors possess specific electrical properties. A substance that conducts electricity is called a conductor, and a substance that does not conduct electricity is called an insulator. Semiconductors are substances with properties somewhere between them. Electrical properties can be indicated by resistivity. Conductors such as gold, silver, and copper have low resistance and conduct electricity easily. Conductors such as rubber, glass, and ceramics have high resistance and are difficult for electricity to pass through. Semiconductors have properties somewhere between these two. Their resistivity might change according to the temperature. For example, at a low temperature, almost no electricity passes through them. But when the temperature rises, electricity passes through them easily. Semiconductors contain almost no impurities, conduct almost no electricity. But when some elements are added to the semiconductors, electricity passes through them easily. Semiconductor comprising a single element are called element semiconductors, including the famous semiconductor material silicon. On the other hand, semiconductors made up of two or more compounds are called compound semiconductors, and are used in semiconductor lasers, light emitting diodes. Now I pass through to Sugan Roshan.
Yes, crystal lattice structure. The unique capability of semiconductor atoms is their ability to link together to form a physical structure called a crystal lattice. The atoms link together with another sharing their outer electrons. These links are called covalent bonds. There are the diagrams for the nucleus of atoms, and the third layer they showing the right hand side is outer orbit or valence shell, and the second one is covalent bonds, and the third one is the round circle is electrons. The Si is silicon nucleus with 14 protons. Okay, the energy band. An atom is consisting of a nucleus and electrons orbiting the nucleus. The electrons cannot orbit the nucleus at any distance in the atomic space surrounding the nucleus, but only the certain very specific orbits are allowed and only exist in specific discrete levels. These energies are called energy levels, and a large number of atoms gather to form a crystal and interact in a solid material. Then the energy levels become so closely spaced that they form a band. This, this is the energy band. Metals, conductors, and insulators are distinguished from each other by their band structures. Their band structures are shown figure below. These are the diagram for the conduction band, and the white color hole is white color round circle is hole, and the blue color circle is electron. And now I will pass to Yuvan Thiran.
Okay, in metals, the conduction band and the valence band come very closer to each other and may even overlap. With the Fermi energy EF somewhere inside, this means that the metal always has electron that can move freely and so can always carry current. Such electrons are known as free electrons. These free electrons are responsible for current that flow through a metal. In a semiconductor and insulator, the valence band and conduction band are separated by a four-binate energy gap, EG, of surface wind and the Fermi energy is between the valence and conduction bands. To get the conduction band, the electron has to gain enough energy to jump the band gap. Once this is done, it can conduct. In semiconductor, at the room temperature, the band gap is smaller. There is enough thermal energy to allow electron to jump the gap fairly easy and make the transistors in conduction band. Given the semiconductor limits conductivity at the lower temperature, no electron possesses sufficient energy to occupy the conduction band, and thus no movement of charge is possible. At absolutely zero, semiconductors are perfect insulator. The density of electron in conduction band at room temperature is not as high as in metals. Thus cannot conduct current as good as metal. The electric conductivity of semiconductor is not as high as metal, but also not as poor as electrical insulator. Okay, this was the conduction band, and blue was electron, and white was hole, and valence was This was N-type semiconduction and P-type semiconduction. Okay, next I'm passed to Avinash.
Hello, okay. Now I'm talking about the band gap for insulators is large, so very few electrons can jump the gap. Therefore, current does not flow easily in insulators. The difference between insulators and semiconductors is the size of the band gap energy. In insulators, where forbidden gap is very large, and as a result, the energy required by the electron to cross over to the conduction band is practically large enough. Insulators do not conduct electricity easily. That means the electrical conductivity of insulators is very poor. Semiconductor crystal used for IC and more is high purity single crystal silicon of 99.99999%. But when actually making a circuit, impurifies are added to control the electrical properties. Depending on the added impurities, they become N-type and P-type semiconductors, pentavalent, phosphorus in bracket P or arsenic in bracket AS are added to high purity silicon for N-type semiconductors. These impurities are called donors. The energy level of the donor is located close to the conduction band. That is, the energy gap is small. Then electrons at this energy level are easily excited to the conduction band and contribute to the conductivity. On the other hand, trivalent boron in bracket B and more is added to P-type semiconductor. This is called an acceptor. The energy level of the acceptor is close to the valence band. Since there are no electrons here, electrons in the valence band are excited here. As a result, holes are formed in the valence band, which contributes to the conductivity. So that's all. Thank you very much.